Alright, so let's get into chapter 1 and in our engineering drawing. So engineering drawings, we need them. We draw, of course, because we want to communicate our ideas, yeah, and we call the design ideas, because without the ideas, right, you can't be able to draw. And how do we develop our ideas? It's come from all the problems that we have with our products, okay? And if you don't have any products, then we think about, what it would be like if we had like this type of product to do blah 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 something, okay? So we designed, let's say, a cup, right? Because you can't actually drink, right? Efficiently with your hand. Can you? Can't, yeah? If you have to use your hand to drink every day, oh, that's a lot of work, yeah? So what if we had a cup so we can be able to just, get the water in a cup and drink, right? So those kind of little problems that we have in living, especially where we're living anyway in the world, and we need so many different kinds of products to help us, okay, to help us to live decently, okay, as human beings. So we create so many different kinds of products to solve all the little problems that we face as we live, okay? And we call that we are solving these problems by designing products or better products, right, to suit all our desires and needs. So today, even worse, yeah, even though we have like so many things, right, so many things, different things, still is not enough, yeah, we gotta make more and more better things, faster things. Our need is never ending. The human desires is too much, right? You need all the time, you want more and more and more and more and more, never ending. So in manufacturing, we gotta do our continuous improvement. Sometimes our products doesn't work, right? So we gotta make it better products, yeah. We have different kinds of markets, right? Depends on the people in the market. As you know, people born and people die, so you always have different groups of people with different kinds of needs. So we have so many different kinds of products. So therefore, we gotta design, yeah, and that's we call it. It's a strategic approach to solve the problems of the world, the problems of the people, yeah. We design. Okay. So how are we going to communicate what we design to make or to realize, yeah, our drawings into products? So the very first thing that we do when you get an idea, we sketch it, okay? That just sketching is expressing an idea. So in this example, he or she, got an idea about a bike, and this bike, right, is putting a heating element, an insulated wall, and all kinds of stuff right in there, yeah. And we call this idea to build, right, to build a better bike or different kind, right, different kinds of bike, depends on your need, of course, the customer's need. Then we're going to get into details drawn, because this kind of sketching is not enough to manufacture, yeah, because people don't understand. You have question, oh, what is the size of this wheel, what is the size and dimension and shape of this, I don't get it. So we need to do a detailed drawing, okay, and that's your technical drawing. We call it engineering drawing, in other words. So here you have everything that you need to build that product, yeah. So we call it as a complete or completed design, yeah. And we need it, yeah, to manufacture. So here in this technical drawing, you can see we have dimension, scale, standard, okay, all kinds of stuff that you need. Then we also use nowadays, of course, computer-aided design to create the 3D models, of your product. or part, so you can be able to visualize it, yeah, from 360 degrees all around. So computer aided design, we call them CAD, CAD, right, in short. And it is another thing that we use to communicate a design. Okay, so when we draw, we don't draw like whatever, we follow rules. Okay, so the rules are in the standards, yeah, that we adopt. So we have a two major group. One is American Society, okay, for mechanical engineers, and this one is an international organization for standardization. So two big groups right there. You can follow one of them, okay, when you draw. So it's going to give you sets of rules, right, controlling how your drawing, okay, got to be. It's going to control the placement of your components on your drawing, okay. Just follow one of these standards. So what else do we use the standards for? We use them, of course, in our drawing, to draw design, to read other people drawing, okay, to read prints, to manufacture, of course, the parts, and also for quality control, and that is to inspect the mistakes, okay. Of course, international communication is very important, and we use the standards. We have to, because all the people in the world speak different languages, yeah, country to country. So in order for us to efficiently communicate between merchants, right, traders, we use the standards, yeah. So that way the manufacturer in other country be able to produce the product that you design in this country, okay. Prints, so that's another name for engineering drawings. We call them prints, yeah, prints. So before a computer, they draw, okay, they draw by hand, yeah, on a board like this, of course, your architect, yeah, product design people, they draw. Of course, we use an engineer drawing kit, that's we call the drafting, yeah, drafting aid, to create your drawing. And then we're going to process that drawing, right, into something called print, yeah. And formally, this is a legally binding document between between the designer and your manufacturer, okay. You're going to design, and then you're going to send it out, hey, make this product. So your factory is going to respond, okay, are you sure you want to make this design, this dimension, before we, like mass produce, confirm. And so that print is really very important, okay. It's kind of like your finalized version of your drawing, yeah. And of course, it's got to be perfect, otherwise your product will come out something wrong, yeah. So you got to double check, triple check, check again, check with different people before you send it out, yeah, because it's your money. And your prints, of course, okay, we use it, yeah, we use it to get the shape description of your product, okay. What you want to make is in your design, your dimension, your tolerance, and your annotation, your partlets, yeah, of your model is in your drawing, okay. And again, I wrote it here, it's a legal print, meaning once you send it, you can change it, okay, because they're going to produce. And that process costs a lot of money, because you have to invest in it to manufacture your model. So your print, yeah, we expect to be so perfect without a mistake, okay. That's why we throw in the QA to check it, okay. You have to check it again and again until we get everything clear, yeah. Even that, sometimes you make a mistake. If your part is big, like aeroplane or ship or something, oh my gosh, everybody in that group is going to get fired out, yeah. So it's not a joke, okay. You can't draw like whatever, you have to draw, and you have to make it every dimension that you draw got to be right and correct, okay. It will pass so many different kinds of steps. We call it the making sure, to check the quality of your drawing so that it is fit for manufacturing, yeah. So here we put, oh yes, all the information that we need is in your drawing for manufacturing and quality control, okay. You got to pass this groove to get to there. Otherwise, you know, it's gonna bounce back. Yeah. All right, so let's get into the drawing sheet. So this is your drawing sheet, and you can be able to see we have different areas. So we have zone right there. We have drawing area, notes. We have title block. Okay, next to the title block is your tolerance and projection. Of course, we put the standard, right? The standard that we follow in there. And then, of course, we have your border. Yeah, this is your border line right there. So here I listed for you border and zone, various blocks, notes, and drawing. It's got to be in your engineering drawing sheet. Then we will get into standard, okay? So the placement of the components in your sheet sides are controlled by the standard you follow, okay? So that's your company, depends on which company you're working for. If you work by yourself, you know, like your own business, then you choose, yeah, what fits to your product that you want to produce. So ASME Y 14.1, ASME Y 14.1M standards is followed in this example, okay? So this is a sheet that follows this standard. All right, the size of your sheet. So I give you two, yeah, different units. So one is in metric, in millimeters, yeah, centimeters, meter, and then you have your British, yeah, inch, pound, unit system right in there, and of course a different sizes here, yeah. So you have 8.5 by 11. Your zone, number of zone, your zones. It's just gonna go back here one slide. These are your zones right there, yeah. The number of it is going to be according to your sheet size, yeah. So 2 by 2, we have 4 by 8, okay, we have 8 by 8, we have 4 by 4, and then we have 4, okay, 6 minus 24 recommended number of zones for this, all right, sheet size for your drawing. So that's your drawing paper size. All right, in matrix, of course, yeah, from A0 go all the way to A3. All right, drawing itself is going to give you the part shape, so you know the shape, okay, what shape you're manufacturing, and also the size. See the dimensions here, so detailed dimensions are given on how to manufacture this part, okay. 3D pictorial and 2D your ortho projection is given to you, so you can be able to see, all right, the shape and size of it in your drawing. So the drawing scale is written in the title block, okay? And you know the title block is right down there. So I'm just gonna go back here, yeah? Here, yeah, title block. So in the drawing, okay, this is your drawing for this part, of course, in this example, yeah? Here's your title block, okay? So what's written is the scale. So when you pay attention, you can see this little sub block in your parent title block is your scale 2:1 is in there. Okay, of course we have different scales right here. Half 1 by 2 is 1:2, and 1 by 4 1:4, and then double scale is your 2:1. Okay, so when you think about the scale, what is it telling me about? Yeah, so every time you have a ratio, so that's your mathematics, so you are dealing with a relationship, yeah, between two things. So the first thing is your drawing, and the second thing is your real world object size. Yeah, so if you go like a 1 unit in your measurement on your drawing, you are actually, you know, like have like 2 units in your actual object in this ratio 1:2. Yeah, so you draw 1 unit on your drawing, it means 2 unit in your actual object. You draw 1 unit, okay, for your 4 units of your object. Okay, so if your object is like, let's say 4 inches, yes, long, you're gonna draw like 1 inch of it, okay, in your drawing. To capture that, again, our proportion matters. It's got to be proportionally related to each other. Yeah, what is each other between your drawing and your actual object? Okay, the first one is your drawing, the second number represents, yeah, your actual object. Okay, it's a scale 2 to 1. See, the drawing is bigger than the actual object because every 2 units of your drawing is going to give you 1 unit of your object. So pay attention to all of your skills, yeah? Then we'll get into 1:1, yeah? So that means every 1 unit of your drawing is a 1 unit of your object. 4:5, 4 units of your drawing is 5 units of your object. Okay, so now you got it how to read the relationship between the two things, your drawing and the actual object in the real world. Alright, zones. So here are your zones. So how to read the zones. Okay, you're gonna start with your letters. You have numbers, yeah, numbers horizontally and letters vertically. So if you want to think about this zone, that's a E6. Okay, if you want to think about the zone right here, so that's a D2. Okay, so if I say go ahead and look at B4, so B and then 4. Okay, this intersection between the two. Just go with the rows and the columns. Yeah. So the zone is just giving you the grid. Yeah. So we can identify the location on your drawing paper. Okay, here example, we're pointing 2.75, and that is in the location in your drawing paper, and we call that the zone F6. Yeah. So for example, if you think about 0.50, this little dimension here, and that dimension is in zone E. Okay, 7. Yeah. So now you get it. Note is another component here in your drawings, and notes is right here. So here in this block, we put the information that we want to communicate, yeah, with the manufacturer. So everything that you want the manufacturer, okay, to know, you put it in there, yeah, especially things that they need to pay attention when they build the product that you draw here, yeah. So this information, we always start by writing NOTE, yeah, note. Number 1, blah, number 2, blah, number 3, blah, 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 yeah? So we put the information that you need to give it to your manufacturer in that box. All right, so that box is here, yeah? We usually write it NOTES, okay? Here, dimensions and tolerances, okay? We are following ASME 14.5, yeah, dash 2009. The next, okay, remove all blurs, yeah, and sharp edges for this product, okay, so the manufacturer know, okay, I gotta do this and this, yeah, and this is your drawing notes, and we use it for clarify your information in your drawing to the manufacturer who is going to build that product or make that product. Alright, title block is right here. Okay, so that is your bottom right at the corner, yeah. So it's going to give you, again, information. Everything is about information. Anyway, we're communicating information of your design of a product or a part, yeah. And again, we put, of course, yeah, all the information that your manufacturer needs, right, in here. Who draw this or size. We will get into details, all right, and later. So right now, you just need to know the title block location on your drawing sheet is right there, okay? So what are we going to put in there, right? We're going to put in the information for the manufacturer about your part, the part that you are drawing, and then the assembly, okay? Again, we're not just putting whatever information. For this example, we're following this standard, yeah, ASME 14.100 for the title block information, okay? Here's an example. This is a problem in your textbook, the same thing. A, okay, is right here, and that is the block, yes. Make sure you pay attention to the little, yeah, little line right there is stop at the top, so therefore it means the entire block, right? So that's your title block. Your B is right here, so the block next to the title block is your tolerancing, yeah, dimension block, I can go back and show it to you, which is this little guy right there. Yeah. And then I'm going to come back, C, okay. C is right here. Yeah. So that's a block. Yes. So in that block, we're going to put, your drafter, your checker, your engineer, your information is going to go right in there. And then your D is right here. Yeah. And that's, you put your company name and address. Your E is your drawing title. Yeah. Your F, okay, is your projection block. We call it projection block, which is this guy. Okay, your angle, your third angle. We have first angle, second angle, and your third angle projection block right in there. Your I is right there, right? So you can see here, so that's giving you your sheet, your drawing sheet size. And then your J is your scale, drawing scale, yeah? And then your K, okay, right here. So DAI is nothing but the design activity identification. Yeah, that depends on your company, of course. And then your L is right here. So that's your actual and estimated part weight. Okay. And then we have RM, and that's your drawing number. Yeah. And then you have your N, of course, here. Okay. And that's your drawing sheet revision. You know, how many times you revise your drawing, you put it there. Sometimes we get rid of this, yeah, when you use a revision block up there, yeah, so it depends on, yeah, your, yes, business. And then your O is going to be right here, and that's your sheet number, yeah. So bigger parts, you might have to use like different sheets, yeah, many different numbers of sheets. It depends on the part you're drawing. All right, then we will get into revision history block is right here, okay? And this is a bigger picture of it. So here, you're gonna see all the changes made, right, in your drawing. And we're gonna put, of course, we're gonna use our zone to locate, oh, okay, in this zone, I made that change. In that zone, this person make that change, okay? So revision history block is how many times you revise your drawing, okay? And what did you revise? So we're gonna put it right in there. And where is it on your drawing? We're gonna put that information right in there. Okay, so here, this is your revision history, your zone, okay? Here, little a, location, of course. Your B, okay, is REV, and that's nothing but revision letter or number, yeah, how many times you revise. Then your C is your description, yeah, of the change, you know, what changes did you do. And then here, D is your revision date, on which day did you do. And then E, has it been approved, okay, put it in there, everything. You can't just go in and change it, whatever you want to do. You can't do that. Every step you do, you got to tell what you did to other people, yeah? So everybody is on the same page. All right, tolerance block is this little guy right there. So what are we going to put in there? We're going to put in our standard, what standard we follow, our projection of our part, and then your dimension and tolerance is right in there of your part, okay, in your drawing. So in the tolerance block in this, okay, here in this parent block, we have sub block. So the first sub block is your tolerance block. It's going to give you the default dimension tolerances. And then the drawing standard, of course, that you use to draw, yeah, your part or the entire, yeah, entire model, depends on the size of your part you're drawing. The projection, of course, yeah, block is just below your tolerance block. And of course, you're going to use which projection method. Are you following the first angle, the second angle, or the third one, yeah, to create that. Okay, let's take a look at it in a real sheet. So here, see, this is your tolerance, and here is your projection, and in this example is a third angle projection. Okay, the standard, okay, is, look at this, the units are given to you, yeah. Since they're putting the standard in a tolerance zone, you can be able to understand, yeah, what are we following? Okay, so here you can also see, look at this, all the tolerances, yeah, these are plus and minus, in details are given to you in this block, yeah. Okay, so that's it for chapter 1. And the most important thing for you to be able to get all main areas, yeah, in your drawing sheet, and of course your scale. If you go back and study, yeah, the scale, the ratio, yeah, 1:2, 2:2, yes, for the relationship between your drawing and the actual object, yeah. Yeah, I think it should be fun, yeah. Okay, yeah, that's it for today. Pardon me for the background sound when I'm recording. There are a lot of background sound, just ignore them, yeah.